Now we are going to start the calculation. We are going to see that how this t-test is executed. So we are going to take the example which is the length of adult silver carps measured from a pond. So we have two groups or two populations, the female silver carps and the male silver carps. So the female silver carps, they are labeled sample number 1, and the male carps, they are labeled sample number 2. So the number of observations from the first group, which is the female silver carps, is 8, and the number of observations from the second group, which is the male silver carps, is 6. Then the mean length of the female silver carps is 72.99 centimeters, and the mean length of the male silver carps is 74.8 centimeters. Then the standard deviation of the length from the mean length is 1.48 centimeters for the female silver carps, and it is 1.04 for the male silver carps. And then the variance is 2.2 centimeters for the female silver carps and 1.08 centimeters for the male silver carps. So why we have labeled female silver carps as sample number 1? Because the variance of the female group is greater than the variance of the male group. Now is the time to put our question, and the question is there any difference in the mean length of female and male silver carps? And our null hypothesis in this case is there is no difference in the mean length of female and male populations of silver carp in the pond. So because this is null hypothesis, so we are going to assume no difference. So there is no difference in the mean length of female and male populations of silver carp in the pond. And the alternate hypothesis is there is a difference in the mean length of female and male populations of silver carp in the pond. So this is our question and our hypothesis. So what should be our next step? Yes, so what are we going to do now? Because we are going to employ the unpaired t-test, so we should make sure that the variance ratio is equal to unity, or the variances of the two samples, they are same. So for that purpose, we are going to calculate the variance ratio, which is the F value. The null hypothesis for this one is the variances in the length of female and male populations of silver carp are same. And the alternate hypothesis is variances in the length of female and male populations of silver carp are different. So these are our null and alternate hypothesis for the F test. Now it is time for the calculation of the F test, and here you can see that we have the table of the descriptive statistics with us on the side, and this is the formula for the F test, in which the greater variance is divided by the lesser variance. And which sample has got the greater variance? The female group has got the greater variance, which is 2.2 divided by 1.08. So our F value is 2.037. So this is our variance ratio, and we can see that this variance ratio is greater than 1. Now we want to see that is it significantly greater than 1, or we can ignore this. So for that purpose, we have to calculate the degrees of freedom, and we are going to calculate V1 and V2. So V1 is the degree of freedom for a sample with the greater variance, which in this case is the female carps group. So 8 minus 1 is 7, which is our V1, and V2 is 5, and this is the degree of freedom for the other sample, which is the sample of the male carps. And why this sample is sample number 2? Because it has got lesser variance. So now we have calculated the degrees of freedom, and now it is time to consult the F distribution table, and the table value of F at probability 0.05 is 4.88. So we can see that our calculated value is less than the table value at probability 0.05. So we are going to accept our null hypothesis for the F test, and we are going to say that variances in the length of female and male populations of silver carp are same. So we can proceed for the t-test. Now we are going to apply the t-test, and this is the formula for t-test. So this formula looks a little scary, but don't get scared of this formula. This is a very simple formula, and it involves the input of only three types of the values: the mean values of both samples, the number of observations of the both samples, and variances of the both samples. So we are going to put in the values. So we put 72.99 minus 74.8. These are the mean values for the two groups. And then we have in the denominator section, we have first 8 minus 1 multiplied by 2.2. So 8 is the number of observations in the first group, which is the female silver carbs, and 2.2 is the variance of the female silver carbs. And then we have 6 minus 1. 6 is the number of observations in the male group, and 1.08 is the variance in the male silver carbs. And then we have 8 plus 6 minus 2. So 8 is the number of observations in the first group, and 6 is the number of observations in the other group. And then in the next factor, we have 8 plus 6, which are the number of observations in both groups, divided by 8 into 6, 8 multiplied by 6, which are also the number of observations. So this is how we input the observations into the formula for t-test. Now the difference between the mean values of the two groups is minus 1.81. And then we have 7, which we got by subtracting 1 from 8. So 7 multiplied by 2.2, and we have 5, which is the degree of freedom for the sample number 2, and we are multiplying it by 1.08. And then we have 12, which is 8 plus 6, 14, minus 2. And then the next factor, we have 14, which is 8 plus 6, and 48, which is 8 multiplied by 6. Now because we are going on to the next slide, so I'm going to copy this same step and pasting it here. So now we are going to solve it further, and we can see that we have now 15.4, which is the product of 7 multiplied by 2.2, and we have 5.4, which is the product of multiplication of 5 by 1.08. And then we have 0.2917, which we got after dividing 14 by 48. The rest of the two calculations are same. Then in the next step, we are going to take the sum of 15.4 and 5.4. So we have 20.8 divided by 12, and the other value is also same. Now I'm again going to copy this step for the next slide. So now we have 20.8 divided by 12, and the answer is 1.7333. So we are going to multiply it with 0.297, and we get 0.5056. And now we are going to take the square root of this value, and this is 0.7111. So now we are going to divide 1.81 by 0.7111, and we get our value of t, which is minus 2.545 in this case. So now we have our test statistic. We have done the calculation of the t value. So you see that this is quite the simple formula. This is not a complicated calculation at all. So the formula looks scary, but it is not scary at all once you understand that how to execute it, and this is a very simple execution. So we have our test statistic with us. What is the next step? Yes, in the next step we are going to calculate the degrees of freedom. And what is the degree of freedom in this case? For the unpaired t-test, the formula for calculation of degree of freedom is n1 plus n2 minus 2. So in this case, we have 12 degree of freedom, and our t statistic is 2.545. Now we are going to consult the t distribution table. So this is our t distribution table, and if you remember the hypothesis that we had the null hypothesis that there is no difference in the mean length of female and male silver carbs, and our alternate hypothesis was that there is a difference between the length of the female and male silver carbs. So what was our alternate hypothesis? Was it two-tailed or one-tailed? Because we were not nominating any of the two samples to have a greater value of mean, so this is a two-tailed test. So we are going to check the values for the two-tailed analysis. And our degree of freedom is 12. So let's see what is our first level of critical probability. This is 0.05, and then the calculated value at probability of 0.05 is 2.179. And then we have our next level of critical probability, which is 0.01, and the table value for this one is 3.055. And our next level is 0.001, and the critical value at this level is 4.318. So now we have the t value, which is 2.545, the degree of freedom, which is 12, and the table values. So the table value at probability 0.05 is 2.1788. So now we see that which of the two values is greater, our calculated value or the table value. So in this case, our calculated value is greater than the table value. So what we are going to do with the null hypothesis, we are going to reject the null hypothesis. Now we want to see the significance at the next level of critical probability, which is 0.01, and the value here is 3.055, which is greater than our calculated value. So it means that we have rejected the null hypothesis because the difference between the mean values is significant, but this difference is not highly significant as our calculated value is less than the table value at probability 0.01, and there is no need to look for the next level of critical probability. So we are going to state our result, and the result is there is a significant difference in the mean length of female and male silver carps. The t-value is -2.55 and probability is less than 0.05. So this is the result that we have. So you see, the t-test calculation is not a complex calculation, it is very simple.